Greetings to Dr. Nase, and in this video I'll be doing this hypothesis testing, and this is purely on my understanding, so I'm so sorry if I did any mistakes, and please to correct me. So the question states that a recent national survey found that high school students watched an average mean of 6.8 DVDs per month with a population standard deviation of zero point 0.5 hours. The distribution of times follow the normal distribution. A random sample of 36 college students revealed that the mean number of DVDs watched last month was 6.2. At the zero point 0.5 significance level, can we conclude that college students watch fewer DVDs a month than high school students? Now I've gathered the information from the question, and I'm so sorry. Don't worry, and I'll post this answer later on. What I gain is A equals to significance level, which is 0.05, and N, which is the sample size, which is 36, and the sample mean X bar is 6.2, and the population standard deviation is 0.5. So the given claim is the mean is less than 6.8. That's what is stated in the question. So there's only two outcomes that we can get from this, which is the claim is either the null hypothesis or the alternative hypothesis. We should not get confused. The mean they are asking is for the school students, and we should not be confused with the mean of the college students. So the null hypothesis with a mean more than 6.8, and the alternative hypothesis with the mean of less than 6.8. There are two possible outcomes for this test, which is to reject the null hypothesis or to fail to reject null hypothesis. Okay, for instance, if the alternative hypothesis is less than, then the test is tend to be left-tailed. If the alternative hypothesis is more than, then it is right-tailed. And if the alternative hypothesis is not equals to, then it is two-tailed. Okay, moving on, we might find it hard to determine whether to continue with a T test or a Z test. In order to find out, we need to refer to our sample size, which is the N. If it's less than 30, we need to carry on with a T test, or if it's more than 30, we need to carry on with a Z test or Z test. So we can clearly see our sample size is 36, which is more than 30, so we need to carry on with the Z test. Since this test is left-tailed with the rejection region of a left-tailed test with a significance level, which is the A equals to 0.05, that contains all Z scores below the Z score minus Z null or Z with the sub-zero, that has a probability of 0.05 to its left. So with this equation, we can determine that the Z score that corresponds with a probability of 1 minus 0.5 minus 0.05, which gives the value of 0.45 in the normal probability table of the appendix. We can clearly see that the probability closest to 0.45 is 0.4505, which is given with the value in the row starting with 1.6, and in the column starting with 0.05, thus corresponding with the Z score, which 1.6 plus 0.05 equals to 1.65. This 1.65 is the critical Z value. Okay, in order to reject or fail to reject the hypothesis, we need to find the Z value, and we need to compare that Z value with our critical Z value, which is 1.65. Okay, I calculated the Z value by using the formula of sample mean minus the hypothesis mean over standard deviation divided by square root of the sample size. Okay, this gives a value of negative 7.20. We can see that the value of Z smaller than negative 1.65 results in the rejection of the null hypothesis, which is H0. Well, this is because the Z score of negative 7.20 is obviously smaller than negative 1.65. So this clearly shows that we reject the null hypothesis, that which is H0. Since we've rejected the null hypothesis, we can conclude that the college students do not watch fewer DVDs a month than high school students. Or we can say that college students watch more DVDs a month than high school students. Also, we should keep in mind that we rejected the null hypothesis, so we believe that the alternative hypothesis to be true. Question 8 states that at the time she was hired as a server at the Grumney family restaurant, Beth Bridgen was told you can average $80 a day in tips. Assume the population of daily tips is normally distributed with a standard deviation of $3.24 over the first 35 days she was employed at the restaurant. The mean daily amount of her tips was $84.85. At the 0.01 significance level, can Miss Bridgen conclude that her daily tips average more than $80? The informations gathered from the questions are significance level of 0.01 and a sample size of 35 and a sample mean of 84.45 and a standard deviation of 3.24. Well, now the given claim is that the mean is more than $80. So the claim is null hypothesis or alternative hypothesis. Now we have the null hypothesis with the mean of at least less than 80, and the alternative hypothesis with the mean of more than 80. So the alternative hypothesis needs to be opposite from the null hypothesis. Well, same as before, if the alternative hypothesis is less than, then it is left-tailed, or if it's more than, then it's right-tailed, and if it is not equals to, then the test is two-tailed. So we can see that this test is right-tailed since the alternative hypothesis is more than the mean. The significance level of 0.01 contains all Z scores above the Z score that has a probability of 0.01 to its right. From this equation, let's determine the Z score with a probability of 1 minus 0.5 minus 0.01, which has the value of 0.49 in the probability table. And now the value closest to 0.49 is 0.4901, which is given in the row starting with 2.3 and in the column starting with 0.03. So the corresponding z-score can be calculated through 2.3 plus 0.03, which gives the value of 2.33. And I forgot to tell that I'm doing the z-test since the sample size is more than 30. Thus, the rejection region then contains all the z-scores greater than 2.33. And for now, our critical z value is 2.33 as well. And as same as before, in order to either reject or fail to reject the hypothesis, I'm going to calculate the z value with the same formula, and I'm going to compare that value with the previous critical z value in order to, as I told you, reject or fail to reject the hypothesis. The z value that I've calculated is 8.86, which is larger than the critical z value, which is 2.33. Since the z score of 8.86 is way more greater than the critical z value, which is 2.33, we reject the null hypothesis, which is the H0. And again, I've did these questions based on my purely based on my understanding, so I know it's not perfect. If there's any mistakes, please do, I'm really sorry, and please do correct me, and I'll try to make it right. Thank you.